Hi, in this video we're going to learn how to perform operations on radicals. At the end of the video, you should be able to simplify radical expressions involving addition and subtraction. We will deal on the next video with multiplication and division of radicals. Let's focus on addition and subtraction, and we will jump with your example right away. Simplify the expression 3 square root of 5 plus 4 square root of 5 minus 2 square root of 5. Just like when adding variables, you can only combine like radicals. Look at your radicals. They are actually all the same. Therefore, this expression is considered like radicals. What you need to do is actually just perform the numbers in front of the radicals, which are 3 plus 4, 7. 7 minus 2 is 5. Afterwards, copy the radicals. You don't add all the radicals, instead you just copy the radicals of the like radicals. It's like 1x plus 2x is 3x. That's how you do operations under addition and subtraction for radicals. Let's have another example. This time, there are actually pairs of radicals. We have the square root of 7s and we have the square root of 3s. We don't combine everything because we can only combine like radicals. So what we can do, you can perform first your square root of 7s. So you actually just do your 6 minus 2, which is 4. And then copy your radical, which is 7. Next, the second pair, since there's no number, it means it's 1. Negative 1 plus 4. Or backwards, 4 minus 1 is 3. You have 3 and then copy your radical. And that's pretty much it. Okay? You only perform addition and subtraction between like radicals. Let's have your pop quiz. What is the result when you simplify 5 square root of 2 plus 6 square root of 2 minus 4 square root of 2? Here are your choices. And the correct answer is number 4. You have 5 plus 6 is 11. 11 minus 4 is 7. Number 4 is the correct answer. Let's have some more examples. Let's have an actual application problem. Find the perimeter of a rectangle whose length is 4 square root of 6 plus square root of 3, which is the longer side, and whose width is 2 square root of 3 minus 4. Here is the illustration of the rectangle. The longer side is 4 times the square root of 6 plus the square root of 3, the same length. Of course, it's a rectangle, and the width has the same length. You have 2 square root of 3 minus 4. We are looking for perimeter. What is perimeter? Perimeter is just the sum of all sides, or you just add all the sides of the rectangle. But since we have radicals as measurements of width and length, we will just combine like radicals. And there are actually 2 pairs of radicals, and there's a constant. Here is your guide. We have square root of 6 radicals, there's square root of 3's, and the last question mark is actually the numbers, which does not have radicals. So for square root of 6, you just have 4 plus 4. You have 8. So you have 8 square root of 6. And then for square root of 3's, there's a lot. You have 2 plus 2, 4. There's 1 here and 1 here. So 4 plus 1, 5 plus 1, 6. 6 square root of 3 square root of 3. And your last missing value, you combine -4 and -4, which is -8. Just combine like radicals. And of course, observe your signed numbers rule. Let's have another example. This time, it's not that easy. How do we combine? They have different radicals here. You have simplify 4, square root of 27 minus 2, square root of 48 plus 2, square root of 20. Well, we learned on simplifying radicals that we can simplify a radical expression by factoring and make sure that one of the factor is a perfect number. Since we are dealing with square root, we are supposed to look for perfect squares factors of the given. So let me show you the template. 27 has a factors of 9 times 3, where 9 is a perfect square. 48 is a little tricky. It's actually 16 times 3. What you can do if you're not sure, you look at your square column on the power table, divide all possible numbers or those numbers to a given. If it does not have a decimal result, then therefore it's one of the factor. So here you have 16 times 3 for the factor of 48. 20 is 4 times 5. Why do we need the perfect square? Because they get simplified. You have square root of 9 is 3. So it becomes a whole number 3. Square root of 3 is left inside your radical symbol. 16 becomes 4. So you have 2 times 4. And 4 becomes 2. And then perform your multiplication. 4 times 3 is 12. 2 times 4 is 8. 2 times 2 is 4. Of course, just copy your radicals. And now, you can now combine like radicals. There's only pair of like radicals, and 5 is not like. It's a different radical. So we can only combine the first and the second. So you just perform the operation. 12 minus 8 is 4. So you have 4 square root of 3. The other one, you just copy it down. And that is your answer for your number 4 example. 4 square root of 3 plus 4 square root of 5. Just remember, you watch out when you factor. If there's cube root here, you look at your cube table. Since there's no number, it means the index number is 2. This is a square root. So to factor, we are looking for perfect square numbers. Let's have another example. Number 5. Again, same case with number 4. We are supposed to factor the numbers inside, and the factors we need is at least one of the factor is a perfect square. Let's begin with 50. 50 has a factor of perfect square is 25. 25 times 2. 72 is actually 36 times 2. 98 is 49 times 2. 49 is square of 7. So, to simplify further, 25 becomes 5 and it will be multiplied to 8. 36 becomes 6 multiplied to 5. Because it becomes a whole number now after taking the square root. Square root of 49 is 7 multiplied to the -2. Perform the multiplication. 8 times 5 is 40. Copy square root of 2. 5 times 6 is 30. 2 times 7 is 14, but it's a negative. And now they are obviously like terms. Like radicals. You have square root of 2, square root of 2 is square root of 2. Therefore, you can perform the operations between them. 40 plus 30 is 70. 70 minus 14 is 56. You just copy the square root of 2 afterwards. That was tough, right? Let's have your next pop quiz. Simplify 5 square root of 3 plus 4 square root of 2 minus 3 square root of 3. Remember, you only You can only perform operations unlike radicals. Here are your choices. And the correct answer is number 3. You can only combine 5 square root of 3 and negative 3 square root of 3. So you just perform 5 minus 3 is 2, and you copy 4 square root of 2. One more. Simplify the expression 3 square root of 12 plus 4 square root of 27. You do remember the example number 4 and 5 that you need to factor and make sure one of the factor is a perfect square so that we can extract the square root of it and multiply to the number outside the radical sign. Here are your choices. And the correct answer is 4. And here is the work to explain. Here is the work. Your 12 is factorable by 4 times 3, and 27 is 9 times 3. 4 will become a whole number 2 from your first. 4 becomes 2 after taking its square root, and only 3 is left inside. 9 becomes 3, will be multiplied to 4, and they will be both having square root of 3. 3 times 2 is 6, 4 times 3 is 12. 6, 12, and then both have square root of 3's. And now it's very clear. You add 6 plus 12. That's why number 4 is the correct answer. You may watch the video again if you need to, and that you will be ready to do your exercise. Thank you.